Alright, so today we're going to learn how to graph a quadratic function. What is a quadratic function? I expect an answer. X squared, yes. Take a point. Alright, so what I want you to be able to do today, not only do I want you to be able to find the solutions of a quadratic using its graph, I want you to be able to, I can graph a quadratic using a table. I can graph a quadratic using a table. Are we ready? Now, first thing, what is a quadratic function?
F(x) equals x squared.
So something with an exponent of 2, right?
Yes.
That's a quadratic. What is a parabola?
The arc and the graph.
It's the graph of a quadratic, guys. Man, how did I figure that out? Alright, so it's the graph of a quadratic. Are you going to say that every time you write it?
Yeah.
Okay. What's a vertex?
It's the middle. It's
Highest or lowest point, right? Alright. So highest or lowest point. And what are solutions?
A-E-I-O-U.
Those are vowels.
Possibly Y.
Those are vowels.
Yeah.
What are solutions?
This is between them.
It would be answers, right? But we talked about them yesterday and we gave them a different name.
Sometimes Y.
Not all the time.
We gave them a different name yesterday.
Why just say them?
What is this? The roots. Yes, take a point. So solutions are the roots or zeros. So it's when the function is at 0.
Going all over these graphs.
Yeah, we don't really need those. Alright, solutions are known as roots, zeros, and x-intercepts.
X-intercept. What's that for your function?
Is at 0. Ready? Alright, so a quadratic function can have 2, 1, or no real solutions. So how many times will it pass through the x-axis if there are 2 solutions?
Twice.
2 times. So I would like you to put a dot at -5 on the x-axis. I would like you to put another dot at 5 on the x-axis.
No, I did that too.
Oh, I did too, don't worry.
Everyone did it.
I did.
Hold on, what we put there?
5 and -5. And I want you to put the vertex at +8 on the y-axis. And then draw a parabola.
Question, like, place the arc, does it not go
-5, 5, 8. Please be quiet so we can talk about this. What'd you say, Travis?
I was like, so like this problem just continues to make the arc, or does it like go back around?
It just continues to make some work.
Say it.
Alright, so then it asks for our solutions. We have two solutions. Where does it cross the x-axis?
-5 and 5.
Negative 5 and 5. Those are your solutions.
It is.
It's crazy.
You said first grade had a hard time.
Not this part.
First.
You know,
Alright, so the next one, I want you to put a dot at, I want the vertex to be at 4, 0.
4.
4, 0.
I think we should call it that.
Yes, I know I should have made the bigger copies, but it's a lot of paper, and it just, it didn't.
4, 0.
It would have been 6 pages, 7 pages by itself,
Saving.
and I don't want to do that.
Because 7 times.
Because we have to pay for our copies.
Saving oxygen.
Alright, so the next dot, I want you to put at 1, 6,
Saving trees. Oxygen.
1, 6. And then 7, 6.
7.
1, 6, and 7, 6. Now remember, our axis of symmetry means it cuts it in half, which means our points have to match up on each side. So if we folded this in half, our points have to touch. That's what we're doing here.
Yeah.
Alright, so now, do you see how the graph only touches once?
Yeah.
Okay, that means we only have one solution, and that solution is 4. Now, if it has no real solutions, how many times does it cross the x-axis? So I would like you to draw an example of what you think that would look like.
What?
I would like you to draw an example of a parabola that has no solutions.
What if it's wrong?
Does it cross the x-axis?
That's the way. I'm done. Okay, I got one.
It doesn't have to be above or below.
Whatever you want it to be.
Wow, yours looks exactly like mine.
Yay!
Yay.
We had time?
That's what I did.
I just
Okay.
shove something down.
Alright, so now this is what we are going to do. We are going to graph these over here. Now you might want to work it out on a separate piece of paper, but you don't have to. We are going to start by, and you do not write this one down. I want you to watch. Now, we're going to start by using a table to solve y equals x squared. Our table has -2, -1, 0, 1, and 2. What are we going to do with those x values to get our y values?
Add.
We did it before.
Subtract. Divide.
We're going to square them. Take a point. Because it has a squared.
Wow.
You plug them in. Man, how did I figure that out?
Probably because you're a math teacher.
Well, because I have x and I have x. And we've done this before.
X plus X.
So if I plug in -2, what's -2 squared?
4.
+4. Alright, what's -1 squared?
1.
What's 0 squared?
0.
What's 1 squared? What's 2 squared?
4.
Now, do you see how it goes down and then back up?
Yes.
Do you notice how on our graphs over here, it goes down and then back up?
Oh, that's dope.
That's what it does. Your numbers are going to repeat. So keep that in mind. Now, where do you think the vertex is of this graph? Who votes for -2, 4? Who votes for -1, 1? Who votes for 0, 0? Why?
Because it's on the x-axis.
Because that's the
Because that's the only one. It's on the x-axis. It's this went down, then back up, and this is the point that stays the same.
What time is it go?
At the end.
Okay.
They're going to call them.
Didn't we Coach Barnes 3 weeks ago?
Alright, so let's do this one.
Did you make
Start that again.
Superior. Nah, you
I would get it work strange.
Or if you would just hush and do your work. You would probably be on honor roll if you would be quiet and do your work. But you don't ever, and you're still talking.
But if it was just core classes, I would.
You don't have a good grade in my class.
But last week,
No.
I was C.
Alright, so now, let's take our -3 and let's plug it in here.
Great.
So you're going to write it as -3 squared minus 2 times -3 minus 3. And we're going to, no, that's not all that matters. We're going to work this out.
Hey, better than not giving it.
Can you stop talking?
So you plug
All right.
the numbers?
You plug in x into each spot that has an x. This is our quadratic function. Does everybody understand?
Yeah.
This is what we're plugging it into. So everywhere we see an x, we're going to put our -3. All right, so what's -3 squared?
Six.
Nine.
Nine.
What's -2 times -3? Positive 6 minus 3. Okay, now we work it out. What's 9 plus 6?
15.
And what's 15 minus 3? So what am I going to put here?
Wow. Oh, that's it. Wow. Word of the day. That's how you do.
Yeah, you just plug it in. All right, so for -2, we have
-2 squared.
-2 squared minus
2.
Times -2.
And 9 minus 3.
minus 3.
Hey, it's not
53a.
4 plus 6 minus 3 is 17.
It's on the same page, Pumpkin. I just moved my paper over.
Pumpkin spice latte instructions.
All right, so what is -2 squared?
4.
All right, what's -2 times -2?
4.
And minus 3. What's 4 plus 4?
8.
And what's 8 minus 3?
5.
All right, now, do I need to do this every time, or can we just say it out loud together?
Just go down and say it out loud.
Okay.
8 minus 3 is...
All right, now we're moving on to -1. I do want you to write the green part every time, so you get in the habit of plugging it in. All right, what's -1 squared?
1.
All right, what's -2 times -1?
2. No, 2.
So what's 1 plus 2?
3.
3 minus 3?
0.
Well, that's not a pattern.
We're going to talk about y in just a second. So this decreased by 7, right? So when we did linear problems, it would decrease by 7 again. But is this a linear equation? No, it's a squared. It means it's going down in different increments. All right, what's 0 squared?
0.
What's 2 times 0?
0.
What's 0 minus 0?
0.
What's 0 minus 3?
-3. 3. You're confused. Just say 0. You want this one?
The pattern
All right.
is 753. The next one's going to be 1. Yes, and then call it down.
Okay. All right, what's 1 squared?
2, 1.
1.
What's 2 times 1?
2.
What's 1 minus 2?
1.
-1. And what's -1 minus 3?
-4.
-4.
Yeah.
You said -1.
I just went down 1.
Okay. All right, now let's plug in 2.
Yay.
All right, what's 2 squared?
4.
What's 2 times 2?
Which one?
4.
What's 4 minus 4? What's 0 minus 3?
-3.
What happened?
Went back to -3 because it liked it better.
Well,
They tried
Okay.
-4. It didn't like it. It was like, nah, -3 was better, so it went back.
Wow.
Tariq, I don't know what you said, son. Say it to me again. I don't know what you said.
We put -3 twice.
Yes. Now, let's look back at this example that we did. Didn't we have our numbers twice?
Yes.
And why did they repeat? Because it goes down and then back up.
Okay.
So what is our parabola going to do? Go down and then back up. Okay?
That's all right.
So what is 3 squared?
9.
What's 2 times 3?
6.
What's 9 minus 6? 3 minus 3?
0.
Are we going back up? Are the numbers repeating?
yes.
So based on this, based on our table, what is the vertex?
Oh, and then
0 and -3.
0 and -3. 1, negative 1, 0.
4 and 0.
1 and negative 4.
Guys, don't just
3,
guess
0,
the
2,
coordinates.
-1,
Like, look
-1,
and
0,
think about it.
Negative 1, 0, negative 2, 5, negative 3. Try to say it.
Do I need to get you out? Like, is that what needs to happen? Because this is annoying. I can't even have class. Now, a minute ago, we said that it was 0, 0 because that one didn't repeat, right?
Yes.
That's where it started over on the repetition. So which one does not repeat?
Negative 3, 12, and negative 2, 5.
As if we plugged in 4, it would keep going back up. It would go to 5. So looking at this, what does not repeat? Where does it start going back up again?
0 and negative
Oh
3.
my God.
0 and negative 3.
No.
I said that to that.
1 negative. Yeah.
I said that.
I said that.
You were guessing, babe.
Alright.
I did appreciate that because you were looking at them, but you were guessing, and I wanted you to be sure. Now, solutions are zeros. And yesterday in our notes, we wrote down for the zeros that y had to equal 0. So did we have any solutions here where y equals 0? Which one?
Negative 1, 0, and 3, 0.
Did we have to graph that to do it? But now we're going to. So everybody get ready to graph. Alright, so all we're going to do is plot these. Do we have room for 12 on this graph?
No.
So we're not going to plot that. Yes, sir.
How do you get the 1 negative 1?
These? Okay, remember we said the solutions over here are zeros, right? And yesterday when we wrote about x-intercepts, we said that y had to equal 0. So which one of these has y equal to 0? At negative 1, 0, and 3, 0. That's where they came from.
So your vertex is always the number that starts.
That starts over again.
Oh, okay.
Alright, so let's plot negative 2, 5. So go left 2, up 5. I know. I'm sorry. I just didn't want to kill so many trees. Alright, where's negative 1, 0? Just left 1, right?
Yeah.
1.
Alright, where's 0, negative 3?
Down.
Go down 3.
Yep, and where's 1, negative 4?
Go to the right 1, go down 4.
Alright, and 2, negative 3 is right 2, down 3. So are our dots matching up on the other side?
Yes.
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 So if we had 4 here, based on our graph, what do you think our y value when x is 4 is going to be? It has to match up, so what would it be? What is this y value?
Negative 2, 5.
What's the y value?
5.
So what would your y value of 4 have to be?
5.
Yep, because it has to match. And then,
How did you get, so what did you do? You did the solution and then the vertex, or what?
right here?
Yeah.
Yes. And then I just plotted my points from here on the graph.
You need a lot of practice.
Oh, so you did negative 3 and 12?
No, we don't have room for that.
What did you do?
I went to the next one. Negative 2, 5.
Okay.
And yes, we're going to keep practicing this over and over and over. Super excited. Alright, are we ready for the next one?
Yes.
So, is the plotting the points on the tiny graph the problem?
A little.
Or is it the math? Well, if you would put your arm through your sleeve and not look like you're waving your missing arm, and then that would maybe help you pay attention. Alright, let's go to the next one. X squared minus 4x plus 4. So let's plug in negative 3. Alright, negative 3 squared minus 4 times negative 3 plus 4. Again, if you need to work this out like this on a separate sheet of paper, work it out on a separate sheet of paper. No judgment, all God's children. Alright, so what's negative 3 squared?
9.
What's negative 4 times negative 3?
Negative 12.
Positive 12 plus 4.
Excuse those students who have an honor roll ticket to the lunchroom. Please release those students with an honor roll ticket to go to the
Good
lunchroom.
time.
Thank you.
Sean gets one. Where's Sean? No, where is Sean?
Alright, we're going to finish 2 in class, and then 3, 4, 5 are your homework.
Okay.
Alright, so what's 9 plus 12?
21.
And what's 21 plus 4?
25.
So what goes in our box?
25.
3, 4, 5.
Alright, let's plug in negative 2. Alright, what's negative 2 squared?
4.
What's negative 4 times negative 2?
8.
Alright, what's 4 plus 8?
12.
And what's 12 plus 4? So what goes in our box?
16.
Have fun. Good job.
Bye.
Alright, are we ready for negative 1? Alright, so we have negative 1 squared minus 4 times negative 1 plus 4. Alright, what's negative 1 squared?
1.
What's the 4? No, yep, show. Bless you.
That's a blizzard.
What's the negative 4 times negative 1?
4.
Alright, what's 1 plus 4?
5.
5 plus 4?
9.
Does it make sense now to anybody?
Yes.
At least that part? Is anybody alive?
I'm pretty sure.
Good.
Now that the fattest ones are gone.
Stop that.
Oh my goodness.
Are you? Well, at least you're holding a pencil so you can still do math.
Wow.
Alright, let's plug in 0. Yes, that's exactly what you heard.
Yes, look.
Alright, 0 squared is what?
Zero.
What's 4 times 0? So what's 0 minus 0? What's 0 plus 4? Magic!
Yeah.
Next one's going to be 1.
You think it's going to be 1?
Yeah, it's a pattern.
Why do you think it's going to be 1?
Because it goes down 9, then it goes down 7, then it went down 5, so it's going to go down 3. And it's going to be 1.
Okay,
Then it's going to go down 1 and be 0.
we'll see. Alright, so let's plug in 1. Let's see if his pattern holds true. So your vote is it's going to be 1, correct? Alright, what's 1 squared?
1.
What's 4 times 1?
4.
What's 1 minus 4?
Negative 3.
And what's negative 3 plus 4?
1.
Alright, he was right there. What do you think the next one's going to be? Think it's going to be 0?
I mean, because it went down 1.
That's fine.
No, it would go down negative.
What do you think it's going to be?
I don't know.
0.
Have faith in your answer.
I go with 0.
Do you think it's going to be 0?
Let's go.
I'm wondering if anybody else sees a different pattern than what he's saying. Alright, what's 2 squared?
4.
What's 4 times 2?
8.
What's 4 minus 8?
Negative
Negative 4.
What's negative 4 plus 4? 0.
I told you.
Yeah.
Now, what do you think is going to happen here?
It's gonna go back up.
You think it's going to start going back up now?
It's gonna be 1.
Let's see. Alright, so we have 3 squared minus 4 times 3 plus 4. Alright, what's 3 squared?
9.
What's not, what's, yum, yum, yum. What's 4 times 3?
12.
What's 9 minus 12?
3.
Negative 3.
Negative 3. What's negative 3 plus 4? 1. So it's starting to go back up.
Yep.
So if we plugged in 4, based on this pattern, let's fill in the next one. If we plugged in 4, what would it go up to? If it has to repeat, what's it going to be? Alright, if we plugged in 5, what would it have to
9.
16, 25.
be? 6 would be,
16.
and 7.
25.
Do you notice anything about these numbers?
It's
Odd and even.
Nope. But yes.
Oh, there, they're squares.
Yes, they're perfect squares. Take a point, both of you.
Hey, how do you get the vortex thing? Vertex thing?
We're about to talk about that. So, what do you think is the vertex?
3, 1.
1 and 1.
That's say 3.
That's my guess.
2, 0, because it's where it doesn't repeat. 2, 0. So you find the point where it doesn't repeat. That's your vertex, this guy right here. Now, our solutions are where y equals 0. So where does y equal 0 on this?
0.
2, 0. So that time it happens to be the same thing. Are you ready to graph it?
Yes.
Yes.
Alright, let's plot our, this, humana. let's plot our vertex. 2 zeros. Everybody go right 2, don't go up any.
Infected.
I just can't.
I believe I can.
That's all I got. Alright, let's do 1, 1. So go up 1, right 1, up 1. And then the matching coordinate. What would the matching coordinate on the other side be? 3, 1. Take a point.
Oh, yeah.
I'm so proud of you. Alright, now plot 0, 4.
I really put my brain to work today.
What would the match? Yeah, but this is a lot of fun. What would the matching coordinate be?
4, 4.
4, 4. Take a point.
Oh,
All right. Do we have room for negative 1, 9?
no.
Yes, we do. Don't be lazy. All right. And what would the matching coordinate be?
Negative 5.
Positive 5, 9, guys. All right. Now let's connect it. It's beautiful.
I'm trying to get the hang of this, but I'm still need a lot more practice.
It is. Now, what do you notice about? We're not done, guys. What do you notice about the parabolas? Do they open up or down? Do they open up
They open up.
or do they open down? Open up. So is it a minimum or maximum? Minimum. Now, what do you notice about the equation? Is x squared positive or negative?
Positive.
X squared is positive.
So,
Look at your paper.
Subject verb.
so if x squared is negative,
It's going to go down, yeah. All right, turn this over. Number 3. Are we ready? We're doing this one together because they left. Yes. Yes. We're probably going to be able to fill out the table of 3 and then graph of 3, 4, and 5 is your homework. All right, so 3, here we go.
D-Day.
Negative 6 squared plus 6 times negative 6 plus 5. All right, what is what is Thank you. And what's 6 times negative 6?
36.
All right, what's 36 minus 36?
0.
0 plus 5?
Someone has to do it.
We're not. We're on air with Blair Asbury.
Oh, we are.
All right, so this one, negative 5 quantity squared plus 6 times negative 5 plus 5.
MLB.
That's 25
Plus 30.
minus 30
Plus 5.
plus 5. All right, what's 25 minus 30?
Negative 5.
Negative
plus
5.
0.
Yes. Yes.
The answer is 0.
The answer is 0. Because 25 minus 30 is negative 5. Negative 5 plus 5 is 0. All right, let's plug in negative 4. Yeah, we got 5 minutes. We can do this.
No.
She's helping you with your company.
Right.
Just making them less problems.
And maybe if we weren't so lazy, more of us would be at the honor roll party. All right,
All
so
these in one
French
sheet.
wasn't a thing. I was
16.
16. And 6 times negative 4
Negative 24.
Negative 24.
plus 5. All right, what's 16 minus 24?
8. Negative 8.
Negative 8.
And what's negative 8 plus 5?
Negative 3.
Negative 3. This is a 5.
I think all A's and B's.
You don't have all 8.
I'm saying
I can't talk to you.
I
I need you to stop. You're making me angry.
All A's and B's except for French.
You're making me
Are you getting no what zero said?
What do you say?
You said I'm gonna let my secrets slip my throat. You said I'm gonna let my secrets.
3, 4, and 5.
Oh, that is not whoa.
All right, what is negative by? What's negative 3 squared?
9.
9.
All right, what's 6 times negative 3?
Negative 18.
Plus 5. What's 9 minus 18?
Negative 9.
Negative 9.
And negative 9 plus 5?
Negative 4. Ooh, I'm getting hang of this now, look.
Look at that.
I wish that I could write. That would probably help.
Physically, you can.
All right, negative 2 quantity squared plus 6 times negative 2 plus 5. All right, what is negative 2 squared?
4.
What is 6 times negative 2?
-12.
Plus 5. Alright, what is 4 minus 12?
-8.
And what's negative 8 plus 5?
-3.
Wow.
Now wait, what's happening?
There's no
It's going back up.
It's going back up. So what would negative 1 be if it's going back up? 0. That's the next one. We don't have to work it out. And if we plugged in 0, what would we get? 5.
Teachers on the 100 hall, before you leave today, please be sure that your room is ACT testing ready. Please be sure your windows are not covered and all desks are facing in the same direction. And that your any printers with scanning capability are disabled and that there are no posters on those walls that can help
Oh, yeah.
Did you know about this?
math equations and things like that.
Throw it on
Thank
your
you
last
guys.
minute.
There's no math
I look
equations.
forward to seeing you in the
Go
morning.
in the whole room.
45. Thank you.
They just threw that on you last minute. What the heck?
Come on, it's not great.
That's your
One.
whole
Stay and help.
Yeah, she turned full on tomatoes.
You want me to stay in help?
I don't want to go to jail.
I got you. I'll come back next week.